In this example, we want to find the next three terms in the sequence and the equation for the general term. Here we're not given any numbers, but what we can do is we can write this down in a chart. So to write this down in a chart, we need to decide one thing to begin with. This is at the beginning when the time is 0, and this is at 1 minute, 2 minutes, 3 minutes, and 4 minutes. This has a little bit of a conflict with our knowledge of n, because n is going to start at 1. So if we start this value at 1, that would work, and then this would be 2, but then you're always going to have to subtract 1 to get the minutes. Either way you do this one would be okay, but I think to keep in line with these minutes here, let's go ahead and just start at 1 minute. So if we draw a table here, we've got n, and maybe we'll do a sub n here for our outputs. We're going to start this with 1, 2, 3, and 4, just to make sure that our time matches with our input, and we'll make that a 0. So we've got 2, 3, 4. We're asked to find the next three terms, so we'll have to go 5, 6, and 7 here. And we've got 3 dots, and then this we have 2, 4, 6 dots. And then the next one we've got, well, let's see, this is 4 times 3, or 12. And then the next one, it looks like we have 3 groups of 8, which is 24. And the next one we have 3 groups of 16 each, which should be 48, I believe. And if we look at the way this is growing, if we look at each individual section here, each individual section is doubling. So here we have 1, here we have 2, here we have 4, here we have 8, and here we have 16. Automatically right away, this is not arithmetic. And if we look at the common difference here, if there was one, actually let's not look at the common difference because it's not common, let's just look at the difference between terms. This, you'd have to add 3 here. Here you'd have to add 6, here you'd have to add 12, so it's totally not arithmetic. We need to figure out what else is going on between these terms. We need to figure out if it's geometric. To figure out if it's geometric, we can see if we double each time we've got the next term, so that's r. R in this case would be 2. Or what you can do is you can just take one term like 12 here, divided by the previous term, and see if that's the same all the way through. So 12 divided by 6 is 2, 24 divided by 12 is 2, 48 divided by 24 is 2. So if we wrote this out, this would be multiply by 2, multiply by 2, multiply by 2, oops, that's a multiplication symbol, multiply by 2, and we could go ahead and use that to figure out the next terms in the sequence. So 48 times 2 would be 96, and if we take 96 and double it, that should be 192. Take 192, double it, and you should get 384. So these guys are our next terms. You know, if you wanted to write this out, it would be a little bit of time to do the dot thing here, but you know, you could write out that the 5th term is 96, 6th term is 192, and 7th is 384. And I'll make a little note over here that that's a 384. Get the lines blurred a little bit here on the other side. The other thing we need to do with this guy is also find the general term. So if you remember back to your notes, you'll notice that the general term for a geometric a sub n is equal to a sub 1 times r to the n minus 1 power. A sub 1 in this case is going to be the first term, and we're going to go with 6 here as the first term. Yes, I know that it's 3 at the very beginning, but what we can do is we could just write the first term as being a 6, and then r would be 2. So this will be 2 to the n minus 1 power. Now, you could clean this up if you really wanted to. You know, you can change the way this looks. This is fine for right now. If we did try to clean this up a little bit, what you could do is you could say that this a sub n is 6 times 2 to the n times 2 to the negative 1 power. Remember, when we have like bases, we add the exponents, so that's the same thing as n minus 1. 2 to the negative 1 is 1/2, and 1/2 of 6 is 3. So we could also state the general term with this equation, and that would work as well. If you take a look at 2 to the 0 power, that's 1, and 1 times 3 is 3. If you do the same thing here, we've got 2 to the 0 minus 1 power, which is 2 to the negative 1, or 1/2 times 6, which is also 3. So either one of these equations will get you right back to your original setup.